To measure the kinetics of malate dehydrogenase, we need to use a UV spectrometer. To begin with, open up UV probe, connect the software to the instrument, open the kinetics module and the method parameters. Type in the wavelength for which the absorbance will be read, the factor which will be discussed in class, the total time for the measurement, and the activity region or the time frame for which rates will be extracted from. The remaining of the tabs do not matter to you. The next thing to do is to blank the UV spectrometer. To begin with, pipette a quantity of your reaction buffer into a quartz cuvette, place it into the cuvette holder in the first cell, and auto zero. You will notice the absorbance in the lower left-hand corner of this module, or of the UV probe software, turn to 000. Once blanked, remove your cuvette and put it off to the side. Next, we need to begin pipetting our calculated reagents into the cuvette. Since buffer's already in there, we'll go ahead and start with NADH. Pipette the calculated quantity of NADH into a cuvette containing the calculated quantity for the buffer at the substrate concentration that you're going to begin with. Be sure to mix thoroughly. Place the pipette tip into the cell deep enough so that it is under the surface of the liquid, and pipette up and down several times. Next, pipette the oxaloacetate. Again, pipette the calculated quantity of oxaloacetate for the substrate concentration that you're expecting to use into the cuvette and mix thoroughly. Place the cuvette back into the sample cell in the front cell. Note that the absorbance for the sample increased to a calculated amount dependent upon the concentration of NADH. Next, we need to set up our first run. Begin by clicking the Start button and typing in the name of the file in the file folder that has been provided to you by your TA. Next, we need to add the enzyme to the reaction mixture. Pipette a calculated quantity of your malate dehydrogenase dilution directly above the reaction mixture. Using a piece of parafilm, seal the top of the cuvette and invert several times. Place the cuvette into the sample holder and hit Start quickly. It is imperative that you do this step very quickly since the reaction begins as soon as you add the enzyme. Notice that the absorbance begins to decrease as time goes on. After obtaining a good data set for the substrate concentration that you're working on, it's time to move on to the next concentration. Again, start by creating a new file for that new substrate concentration, and then follow the procedures for the previous substrate concentration. You will notice that as you decrease the concentration of the substrate, the rate of the reaction decreases as well. Repeat these reactions at different concentrations of your substrate. There is a rule of thumb when determining the kcat and km for an enzyme. If you double the substrate concentration and the rate doubles, you are below the km for that substrate. However, if you double the concentration of the substrate and the rate does not double or stays the same, you are above the km of the substrate. You can analyze your kinetic data in the same UV probe software. To begin with, open up a Lineweaver-Burk analysis. Right-click and hit New. Name this analysis whatever you would like in the folder that was assigned to you by your TA. You need to next load the data set. Double-click on your data sets. Double-click once more and include your raw data. Once your data sets are loaded and you have the substrate concentrations annotated under the substrate concentration column, you can click on the Stacked tab in the lower right-hand panel. This will provide you a Lineweaver-Burk plot of the kinetic data that you just obtained. Notice that your Lineweaver-Burk is not quite linear, and that's because we have yet to adjust the time frames for which these reaction rates were recorded. There are several ways you can look at your data. You can open up your raw data file or your activity table, and it'll present you the data file at all time points recorded and your absorbances that go along with each substrate concentration. The best way to view the data is by clicking the kinetic analysis or the rate analysis in the top right toolbar. The software allows you to change the time frame from which the activity was measured. In the top right-hand quadrant, click on the vertical bars in your real-time assay and move them from left to right to change the time frame for which the activity assay is measured. You'll have to repeat this for all of your substrate concentrations and the activity assays that you measure for them. Remember that you are measuring the initial rate of the reaction, not the entire reaction. The initial rate of the reaction generally occurs in the first 10% of the substrate consumed. Therefore, you will be measuring very small time frames of the entire reaction. You will need to remove all your data sets in your Lineweaver-Burk analysis. They are no longer useful to us. Manually load all your data sets that you just reanalyzed. Load all your data sets into the Lineweaver-Burk module and type in their concentrations. Once done, the Lineweaver-Burk module will provide you a Km and a Bmax. In this scenario, our Km was around 30 micromolar. However, our top concentration for a substrate was 100 micromolar. Typically, when you're finding Kcats and Kms, you run your substrate concentration out to 10 times Km. In this case, our Km is estimated to be 30 micromolar, therefore our top concentration needs to be around 300 micromolar. Therefore, we need to add two more data sets, a 200 micromolar and 300 micromolar data set. Once we've obtained our new data and analyzed the data set, we can add it to our line-weaver-burke module. Notice that our 300 micromolar, or our 10 times Km, is actually slower than our 200 micromolar, or roughly 6 times Km. This could be due to substrate inhibition, or it could be due to poor pipetting. Rerunning the 300 micromolar reaction first to determine if it was poor pipetting is the right thing to do. Do not assume that it's just substrate inhibition. Notice when we add our last data set, or our 200 micromolar analysis, our line-weaver-burke becomes very pretty and very straight. We obtain a new Km and a new Vmax, and our R squared value is around 0.995. Perfect. Once you're happy with the data that you have collected, export your files as a ASCII2 or a CSV file. You can use those files in Excel to analyze your data or any other data analysis software.